This resource is the second in a series on derivatives. We will explain the concept behind derivatives and formally define them. We will discover how to find the derivatives of various forms of functions, including polynomials and trigonometric functions. We will consider how to differentiate products, quotients, and composition of functions. We will also consider applications for derivatives and how they relate to real-world situations. Suppose we have a simple monomial function, like f of x equals x raised to the third power. We want to find a general rule for the derivative of the function. Recall that the definition for finding the derivative f prime of a function is given by the limit as h approaches 0 of the quantity f of x plus h minus f of x divided by h. So we want the limit as h approaches 0 of the quantity x plus h cubed minus x cubed divided by h. Expanding the quantity x plus h cubed, we get x cubed plus 3x squared h plus 3x h squared plus h cubed. Subtracting, we have the limit as h approaches 0 of the quantity 3x squared h plus 3x h squared plus h cubed divided by h. Dividing, we are left with the limit as h approaches 0 of 3x squared plus 3xh plus h squared. Taking the limit, we find our derivative. The derivative with respect to x of x raised to the third power is 3x squared. But what happens if our polynomial is a little more intense and has a coefficient involved? Let's look at an example. Suppose we want to find the derivative of the function f of x equals 3x squared. Once again, we will work from the formal definition of a derivative. So the derivative will be the limit as h approaches 0 of 3 times the quantity x plus h squared minus 3x squared divided by h. Expanding, we have the limit as h approaches 0 of 3 times the quantity x squared plus 2xh plus h squared minus 3x squared divided by h. Distributing through the parentheses, f prime will be the limit as h approaches 0 of 3x squared plus 6xh plus 3h squared minus 3x squared divided by h. Combining like terms, the derivative becomes the limit as h approaches 0 of 6xh plus 3h squared divided by h. Dividing, we have the limit as h approaches 0 of 6x plus 3h. Taking the limit, the derivative with respect to x of 3x squared is 6x. But how will we find the derivative of a polynomial with more than one term? If f of x equals x squared minus 7x plus 4, what is f prime? As before, we will employ the formal definition for derivatives. So we have the derivative equal to the limit as h approaches 0 of the quantity x plus h squared minus 7 times the quantity x plus h plus 4 minus the quantity x squared minus 7x plus 4 divided by h. Expanding and distributing, we have f prime equals the limit as h approaches 0 of the quantity x squared plus 2xh plus h squared minus 7x minus 7h plus 4 minus x squared plus 7x minus 4 divided by h. Combining like terms, we are left with the limit as h approaches 0 of the quantity 2xh plus h squared minus 7h divided by h. Dividing, we have the limit as h approaches 0 of 2x plus h minus 7. Taking the limit, we find that the derivative of the polynomial function x squared minus 7x plus 4 is 2x minus 7. We had to do a lot of algebra and work to find this derivative. It sure would be nice if there was an easy method to find the derivative of any polynomial. Luckily, there is. Suppose we have a monomial function f of x that looks like a constant a multiplied by x raised to the power k. The derivative f prime of x will be a multiplied by k multiplied by x raised to the power k minus 1. To find the derivative of a polynomial with more than one term, we just apply the rule to each term. Let's look at a couple of examples. Suppose we have the function f of x equal to 7x to the fourth minus 5x to the third plus 6x squared plus 11x plus 4. We want to find the derivative of this function. Using the rule for polynomials, f prime of x will be 7 times 4, x to the 4 minus 1, minus 5 times 3, x to the 3 minus 1, plus 6 times 2, x to the 2 minus 1, plus 11, x to the 1 minus 1, plus 4 times 0. Because a constant number like 4 can also be written as 4 times x raised to the 0 power. Simplifying, we have the derivative equal to 28x to the third minus 15x squared plus 12x plus 11. Let's see another example, just to make sure we understand how this rule works. Suppose we have f of x equal to 9x raised to the power of 35 plus 51x raised to the power of 29 minus 5x squared plus 743. Finding the derivative, we have 9 multiplied by 35, x raised to the power of 35 minus 1, plus 51 multiplied by 29, x raised to the power of 29 minus 1, minus 5 times 2, x raised to the power of 2 minus 1, plus 743 times 0. So our derivative will be 315x to the power of 34 plus 1479x to the 28th power minus 10x.